Okay, problem 7.14. Calculate these limits. Okay, so these are going to be all of them applications of L'Hopital's theorem, right? So let me write it here. So L'Hopital says that if any limit, right, the limit when x goes to a of f divided by g is either 0 divided by 0 or infinity divided by infinity, so these two are in terminations, and we know that the limit of the derivative of f divided by the derivative of g is L, then the limit when x goes to a of f divided by g is the same L, right? So it's not that this limit is equal to this limit, it's just that this limit is equal to this when this thing is we have a 0 over 0 in termination, or infinity over infinity, and this limit exists. Okay, remember, sometimes this limit doesn't exist, so we can't use this result to compute our limits. Okay, but let's start. Okay, so the limit when x goes to 0 of e to the x minus sine of x minus 1 divided by x squared, right? So this is when x goes to 0 with substitute, so this is 1 minus 0 minus 1, 0 divided by 0, right? So then we can apply L'Hopital's rule and say, well, let's compute the limit of the derivative of this. So this is e to the x minus the cosine of x divided by 2x. And this is, again, this is going to be 0, right? So we can apply, 0 divided by 0. So this we can apply L'Hopital rule again, and we get e to the x plus the sine of x divided by 2. And so this is 1 divided by 2, 1/2, right? And so because this limit is 1/2, then we know, because of L'Hopital's rule, that this limit is 1/2 and this limit is 1/2, okay? So I keep writing these equals, but these are not equals unless we get to finite result, okay? Let's see. Second, it's the limit when x goes to 0 of the logarithm of the sine of 7x, the absolute value of the sine, divided by the logarithm of the sine of x. And in this case, we have the sine of 7x goes to 0 as x goes to 0, and the logarithm of 0 is minus infinity divided by minus infinity. So again, we have this, okay? And so we can apply L'Hopital's rule and say maybe this is equal to this if this limit exists, right? So this is, let's say, 7x divided by the absolute value of 7x divided by, not 7x, 7 divided by, sorry about this. This is not the logarithm of the sine. The derivative of the logarithm of the absolute value of the sine, right, is 1 over the sine of x times the cosine of x, and then times the derivative of this. Okay, so this is 7 cosine of 7x divided by the sine of 7x times, and then or divided by, and then we have the sine of x, and let's see, divided by the cosine of x. Okay, and we can get rid of the absolute values here, because when x goes to 0, either the sine of x and the sine of 7x are going to have the same sign. So this fraction is going to be positive, right? So then we have the limit of, let's say, the limit of this is going to 1, the limit of this is going to 1, so we can actually get rid of them, right? So we have 7 times the limit when x goes to 0 of the sine of x divided by the sine of 7x. Okay, and this is 0 over 0, so we can apply again L'Hopital's rule and say this is the 7 times the limit when x goes to 0 of the cosine of x divided by 7 times the cosine of 7x. And this goes to 1, so this is 7 divided by 7, right? Or in other words, 1. Okay, let's go for part 3. The limit when x goes to 1 on the right of the logarithm of x times the logarithm of x minus 1. Okay, so the logarithm of x is going to go to 0, right? And the logarithm of x minus 1 is going to go to minus infinity. Okay, so one way to write this is actually in a way that we can apply L'Hopital's theorem is to say this is the logarithm of x minus 1 divided by 1 over the logarithm of x. And now we know that 1 over the logarithm of x is going to go to plus infinity, right? And so this is okay. We can apply L'Hopital's rule and say this is the derivative of this, sorry, the limit when x goes to 1 on the right of 1 over x minus 1 divided by the derivative of 1 over the logarithm of x. And the derivative of 1 over the logarithm of x is minus 1 over the logarithm of x, all of this squared, right? And then times the derivative of the logarithm of x, right? Which is 1 over x. So this is minus 1 over x times the logarithm of x, all of this squared. Okay, we can rewrite this like this. This is the limit when x goes to 1 on the right of x logarithm of x squared. Okay, remember this is not the logarithm of x squared, it's the logarithm of x squared. This is x minus 1. And then we get this is, how to say, this is, well, we can get rid of the 1, right? Let me see, because this is the product of the limits, is the limit of the product. So we have, this is the limit when x goes to 1 of the logarithm of x, sorry, the logarithm of x squared divided by x minus 1 and multiplied by minus here. Okay, and now we can, this is going to go to 0, this is going to go to 0, so again we have a 0 over 0, we can apply L'Hopital's rule again, so this is minus the limit when x goes to 1 on the right of 2 times the logarithm of x times 1 over x, right? And this is 1. And now we have minus 2, and then the limit when x goes to 1 of the logarithm of x divided by x, right? But then this is going to be 0, right? Because the logarithm of x goes to 0. So this limit is 0. Okay, so because this limit is 0, this limit is 0, this limit is 0, and this limit is 0. Okay? Good. Let's go to part 4. Part 4 is the limit when x goes to infinity of x to the 1 over x, right? Now, here we don't have a fraction, right? How do we express this in terms so that we can solve this using L'Hopital's rule? Well, the idea here is that x to the 1 over x is the same as e to the 1 over x times the logarithm of x, right? And the limit of e to the something is the same as e to the limit when x goes to infinity of that something. So this is the logarithm of x divided by x. Okay, so let me write it here. This is the limit when x goes to infinity of the logarithm of x divided by x, and this is going to be infinity divided by infinity, so we can apply logarithm's rule. So yeah, L'Hopital's rule, and differentiate both sides, and we have 1 over x, right, divided by 1, and the limit of this is going to be 0, and so this is e. Okay. Let's go part 5. Okay, so let's do part 5. Okay, in part 5 we have the limit when x goes to 0, 1 plus x to the 1 plus x minus 1 minus x squared, right? Divided by x cubed, right? So here we have a function, let's call it f, right? 1 plus x to the 1 plus x. That's going to have complicated derivatives, right? Because we can write this as e to the 1 plus x logarithm of 1 plus x, right? And so we know that the value of f at 0 is going to be 1 to the 1, so it's 1, minus 1, minus 0, 0 over 0. So we have to apply L'Hopital's rule, right? So then we have the limit when x goes to 0, and let me just write f prime, right? I'm going to write this is f, right? I'm going to write f prime minus 1 minus 2x, okay? So if we compute the derivative of f, right, we have the derivative, well, it's 1 plus x, let's say it's f, right, times the derivative of the exponent, which is the logarithm of 1 plus x plus, and then we have 1 plus x divided by 1 plus x, 1, okay? F prime at 0 is going to be f at 0, which is 1. Let me write here. F at 0 is 1. F at 0 is 1 times 0 plus 1. So the derivative at 0 is 1, 2, right? So then we have 1 minus 1, 0 over 0, okay? So then we have to differentiate again. So we have the limit when x goes to 0 of the second derivative of x minus 2 over 6x. And we're going to see now that the second derivative of f is 2 at 0, right? So the second derivative is f prime times the logarithm of 1 plus x plus 1, right? Plus, and then f times the derivative of this, but the derivative of this is just 1 divided by 1 over 1 plus x, right? So the second derivative is 1 times 1 plus 1, because the value of f at 0 is 1, so the value is 2, right? And again, so this is 0 over 0, we need to differentiate again the limit when x goes to 0 of the third derivative of x divided by 6, okay? And now the third derivative of f, let me write it here, for instance. The third derivative is going to be the second derivative of this times the logarithm of 1 plus x plus 1 plus the derivative of this times f prime, so f prime divided by 1 plus x, and then plus the derivative of f divided by this, so this is 2 times this, and then minus f divided by 1 plus x squared, okay? This is the third derivative. Now the third derivative at 0 is going to be 2 times 1, so 2 plus 2 minus 1, or in other words 3. So this is 3 divided by 6, in other words 1/2. Okay? And now let's do the last part. Six is the limit when x goes to infinity of x times the tangent of 2 over x minus the tangent of 1 over x. Okay. And I think for me the easiest way to do this one is to actually change the variable. Okay, let's call y 1 over x, right? So now the limit when x goes to infinity is the same as the limit when y goes to 0, and this is, let's see, the tangent of 2y minus the tangent of y divided by 1. So this is, you can take so multiplied by x is the same as divided by y, right? So this is equal to y. This is the tangent. The tangent goes to 0 at 0, so this is 0 divided by 0. So we can now apply L'Hopital's rule here. If you apply L'Hopital's rule to this one, when you have the tangent of 2 over x minus the tangent of 1 over x divided by 1 over x, this can get hard because of the derivatives, right? So we have 2 times the derivative of the tangent, which is 1 plus tangent squared to y minus 1 minus the tangent squared y divided by 1. And then here this is the derivative, sorry, tangent is going to be to 0, this is going to go to 0, so this is 2 minus 1, 1. Okay? And that ends the problem.